All right, this example says the instantaneous rate of change of the vector value function is given by 4t comma 5. So that's a vector value function. It's the derivative. It says if f of 1 is 9, 7, then find f of 2. So it's the stuff we just did in example 3, but adding one extra step. Once we find that initial position function, or the initial vector value function, plug in 2 and see what you get. So if I'm given f prime, if I integrate f prime, I'm given the original function f. So I need to do that. F of t is equal to the antiderivative of 4t5. So f of t is equal to 2t squared plus c1 plus 5t plus c2. Using the initial condition, if I plug in 1, I get 9 for the x component. So 2 times 1 squared plus c1 is equal to 9. So 2 plus c1 is equal to 9. So c1 is equal to 7. And, oops, let's put a plus sign here. 5 times 1 plus c2 is equal to 7. So c2 is equal to 2. So I know f of t now is 2t squared plus 7 and 5t plus 2. It's a vector value function, but an extra step now, find f of 2. So just plug in 2 for your vector value function. Plug in 2 here, plug in 2 here, and we get 15 and 12. All right, so there's the answer. All right, I think I'm gonna finish this video up just by writing out the problems, just losing my voice, but I want to make sure at least you have the correct answers. I'm just not gonna really talk through it. Okay, so given the derivatives, to find the position, I take the antiderivative of the derivative. So that's how it's the same thing. So use your initial condition. So final answer, vector value function for the position. All right, so this one's just doing a couple steps. We're trying to find f. So given the second derivative, we're going to find the antiderivative to get to the first derivative. And once we have the first derivative, we use the initial conditions to find and do the antiderivative of that to get the initial function f. So I'm taking the antiderivative of the second derivative. using the initial condition. Alright, so once I have the first derivative, if I find the antiderivative of that, I would get just the normal function f. I'll call this C3, it's a new C. Okay, use your initial condition. So final answer. Here we go. All right, last one is calculator active. It says gives you the velocity vector. The particle is at, so it gives you a position. How far is the particle from the origin at time t equals 1? So what we're going to do is find the position of the vector, the terminal point, when time t is equal to 1. And then from there, we'll see how far is that away from the origin. So to find the position, I need to find the antiderivative of the velocity function. And I need to do that, I need to do that from 0 to 1. Because I'm given its position. So this is like your fundamental theorem of calculus inside of a vector value function. So the integral from 0 to 1 So I'm going to take this part and say, okay, this is the x. So this would be the position. What can we say this? I want to say the x position at 1 minus the x position at 0. So this could be done in the calculator. It's pretty easy. This would be 2 is equal to x of 1. And I know the position, the x position at 0 is 1. So the x position at 1 would be 3. Okay. The y component, this is why this one's calculator active. The y at 1 minus the y at 0, the y position. So this is done in the calculator, 0.81. And we don't know what y at 1 is, but I know y of 0 is 1/2. That's the position, the y position. So y of 1 is equal to 1.311. Oops. That's 31. All right, so the position, are you curious? Position would be 3, 1.31, I think. So it says if time particle, how far is it from the origin? So what this represents is where the terminal point is on that vector value function. So the terminal point's at 3, 1.3. So I've got to find what's that position. So that's just your distance formula. It's the whole idea behind magnitude. So this would be 3 squared plus 1.31 squared is equal to that distance squared. So solving that would be 3.274. All right. So I couldn't talk to this one, but thank you for watching, and I hope it helped. If you have any questions, ask me next time I see you in class. Bye.